Okay, guys, today we're gonna go over this problem called the problem of Hanoi. So this is called the problem of Hanoi. So there are three pins. Let's say the first pin is A, second pin is B, third pin is C. In the A pin, there is n number of discs. As you can see, discs are kind of built as a pyramid. So the bottom disc is going to be the longest, followed by the next disc, followed by the next disc. Each of these discs is removable. So you can move one of these discs to the other pin. That would be one move. So if you move the top disc to pin B, that would be one move. If you move the second pin to C, that's one move, right? The problem of Hanoi is if you can is how many move it takes to get, let's say, move all of the discs, the end discs from pin A to pin C. So that's the question. How many move how many move does it take to move all the pins from pin A to pin C if there are n number of discs? Right. We are so there are some requirements, right? Namely, a larger disk cannot be on top of a smaller disk. For example, let's say if you move like pin these two disks to, let's say, B or C in such a way where you have a disk here and you have a bigger disk on top of it. Well, that's no. You can't do that because that would mean that you have a bigger disk on top of a smaller disk, and that is prohibited. Okay. So how would we solve this problem? And now, the traditional approach to solving such a problem is through recursion. So solution by recursion. And I think the best way to kind of see how this works is by looking at some examples of how this might work. So suppose that we have three pins, pin A, B, pin C. Suppose that we only have one disc. How many moves does it take to move this disc, to pin C? This should be obvious. One move. Right? This is pretty obvious. Same question. Let's say we have three pins again. This time we have two discs. How many moves does it take to move there's two discs to pin C? So I want you guys to sort of imagine how this might work. Like, I think the best way is to visualize how this might work. So this top pin, we can imagine that this top pin right here, we can move it to pin B, right? And then we could move the larger disc to C, right? And then we can move this smaller pin on top to pin C. So how many moves is that? So it would be from A to B, that's one move. From A to C, that's one move. And then from B to C is one move. So it would be how many moves? Three moves. The problem becomes more complicated when we maybe start thinking about three pins. So you have 3 pins. How are we transpose all of the pins to pin C? How do we transpose all of this to pin C? I want you guys to think about it. So we know, I think this is the best way to think about this, maybe is to kind of think about how we solve the case where there is only two disks in pin A. We are able to transport all of the disks, the two disks, from A to C in 3 moves, right? Suppose that means that, suppose we have this 2 disks here. How many moves does it take to get this two disks to pin C? According to the previous problem, we are able to do that in 3 moves. So that means that, so this is, suppose that this is 3 moves. 3 moves, right? How many moves does it take to transpose this bottom disk to, let's say, pin B? That would be 1 move. And then we met now, okay, so now we have, so pin B, after 3 plus 1 move, we have the big disk on pin B, and we have the 2 disks, smaller disks, the top two disks on pin C. Well, all we need to do is move the top, the 2 disks on C back to B, right? And how many moves do we need to do? Well, so from C to B, that would be, well, given our previous problem where there's 2 disks and takes 3 moves, right? So it's again going to be 3 moves. So the total number of moves to move 3 disks is going to be 3 plus 3 plus 1, 7 moves. So we do see, so we are starting to see a pattern here, right? The pattern seems to be that, we don't necessarily need to solve, like the way we solve this problem is not to look at, how do I move the n disk from pin A to pin C? Rather, how can I reduce this n disk problem to n minus 1 disk? And if we can solve the n minus 1 case, then we could solve the n disk case, right? So now we're gonna do the general problem, right? Which is gonna be n number of disks. Again, we have pin A, pin B, pin C, and this time it's not gonna be limited to 3 disks. We're gonna generalize it to n number of disks. Right, n number of disks. Maybe some notation is good. So we want to know the function of the number of, so suppose n is a number of disks in pin A, and that this function, what is this? The number of n is a function that tells you how many move it takes to move from A to C, to C, right? first we can start thinking about the n minusing one case. So we look at, so there are n number of disks here, right? We look at the n minusing one case. We look at all of these disks smaller than the bottom disk, right? And so this would be the n minusing one disk case, right? If we have a function, all right, that tells the number of move it takes to move the n minusing one disk to another pin, let's call it b, right? Let's call it b. Let's move the n minusing one disk to b. So let's do first. We want to move n minusing one disk to b, right? And how many moves does it take to move to b? Well, it's gonna be n minusing one, right? Second, how many moves does it take to move the bottom disk to, let's say, C? Well, once we move the n minusing one disk from pin A to pin B, then we are pretty much open to lift the bottom disk from A to the pin C in one move. Move big disk from A to C in one move. Right. So it's going to be one move. This is going to be function n minusing one move. Now remember, now B has n minusing one. So right now there is like n minusing one disk, and now C has this giant disk now. All we need is the number of move it takes to move n minusing one disk to the pin C, right? And we know how many move it takes to do that, right? It would take the function of n minusing one number of move from pin A to pin C. Third, move n minusing one disk from B to C in n minusing one move. So if we combine all the move it takes to move n disk from pin A to pin C, right? It would be the sum of each one, right? So the number of move it takes to move n disk, right, is gonna be equals to the number of move it takes to move n minusing one move plus 1 plus n minusing one move. So at this value is to move n minusing one disk from pin A to pin B, right? And then this term is for moving the giant disk, bottom disk, from pin A to pin C in one move. And this term, right, is to move the n minusing one disk from pin B to pin C. And when we combine all of it, it's going to be 2 times n minusing 1 plus 1. So this is actually a recursive function. A recursive function. Okay. And we could look at some possibilities, right? We could maybe draw a table where n is on the left and this function number n to be, so if there is one disk, right, we know that it takes one move. If there's two disks, we know that it takes how many move? We know that it takes three moves. Three moves. If there are three disks, it's gonna be, we're gonna use this function, right? It's gonna be 7 moves. Okay. If there are 4 disks, it's going to be 9. If it's 5 disks, it's going to be 11. So do we see a pattern? Is there a function, a function where the input is n and the output is these value here on the right side of the table? There is, right? And it's this function. The function is 2 to the power of n minusing 1, right? Well, you can see that if n is 1, then it's going to be, so if, let's say, this is the function, so by the way, how do I come up with this equation? Well, you just have to eyeball it. This function is very much similar to, if you look at the 1, 3, 7, 9, and 12, it's very similar to the exponential function, right? And typically that's how mathematicians kind of spot a pattern oftentimes. So if n is 1, then it's going to be 1. If n is 2, then it's going to be 3. If n is 3, it's going to be 7. If n is 4, it's going to be what? Say, this is going to be 2 times 2 times 2 times 2. That's 4, 6. This is 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 16. So wait a minute. So is it? This is 16. 16 minusing 1 is 15. So this is 15. And this is 4. Oh, yeah, so this is 15. So you're looking at, okay. I think I made a mistake here. It should be here. This thing is going to be, yeah, this is going to be 15. I think I made a mistake here. So this is actually 15. So so for this recursive function, it's going to be doubling the 7. It's going to be 7, 7, it's going to be 14, 15, right? It's going to be 15. And then if you double this thing, it's going to be 30, right? 30, 30, 31, right? Okay, so we have a recursive function and we have a direct function that gives us the number of move it takes to move end this from pin A to pin C. All right, thank you.